This is my modeling project on the bulk flow filtration in the capillaries by me, Amanda Hernandez, for Bio 202 with Dr. White. So first we start off with the blood flow, which starts with the arteriole to the capillary bed, then venule. The arteriole will deliver blood into the capillary, which is a thin wall, so it will allow for diffusion of gases and waste. After that, the blood flows into the venule. The filtration will occur in the arterial part of the capillary bed. This is because of hydrostatic pressure. Hydrostatic pressure wants interstitial fluid to leave the blood. It is responsible for filtration. Capillary hydrostatic pressure forces H2O solutes through gaps into continuous capillaries. After filtration pushes out 90% of the interstitial fluid, the fluid is then absorbed into the venule side of the capillary bed. It is reabsorbed due to osmotic pressure. Osmotic pressure helps suck in the fluid because it has a high concentration of albumin. Filtration happens through hydrostatic pressure, which pushes interstitial fluid out, and through osmotic pressure, which reabsorbs fluid through the venule side. Extra interstitial fluid that is not reabsorbed goes to the lymphatic capillaries to make it back to the bloodstream. Colloid osmotic pressure happens when suspended proteins aren't able to cross the capillary walls. Interstitial colloid osmotic pressure happens because interstitial fluid contains small amounts of suspended proteins. So here the red arrow will symbolize for capillary hydrostatic pressure. The orange arrow will symbolize for blood colloid osmotic pressure, and the black arrow will represent net filtration pressure. On the arterial end, the capillary hydrostatic pressure will be higher than the blood colloid osmotic pressure, thus pushing out fluid, which then causes filtration. However, on the venule side, the blood colloid osmotic pressure will be greater than the capillary hydrostatic pressure, which will make fluid move in, causing reabsorption. The net filtration pressure is the difference between the net hydrostatic pressure and the net osmotic pressure. The net fluid movement is calculated with filtration. If the value is positive, fluid moves out of the capillary and into the fluid, but if the value is negative, fluid moves inside the capillary. And now we move on to the lymphatic ducts. Within the lymphatic systems, the main vessel is the thoracic duct that passes upward and in front of the spine, draining into the left internal jugular and then into the left subclavian vein. The right lymphatic duct is a very short vessel that receives lymph from the right side of the head and empties into the right subclavian vein with the internal jugular vein as well. Thank you for giving me the time to listen to my presentation on the bulk and filtration. I really hope I didn't bore you to death.